Hello everyone. Today we will talk about Orange and how you can use Orange to create a machine learning pipeline for datasets in healthcare. So where do you get Orange from? If you open a browser and you Google for Orange 3 download, you will get to a website which gives you different versions for Orange, for example, for Windows, for Mac, and for Linux. Once you've installed your individual software tool, you can start straight away with interactive data visualization, visual programming, and create machine learning pipelines for supervised machine learning as well as for unsupervised machine learning. So there are many features. Orange is quite a powerful tool. It's not only about creating pipelines, but you can also visually explore your data set. You can create box plots and scatter plots and join different data sets. You can further clean data sets. And it's quite a powerful tool. You can also transfer the data from Orange into Python, and from Python you can further modify it or link it with other Python code. So there are two options how you run Orange. Either you install this as a standalone tool, or if you want to go one step further, you can also install this in the Anaconda distribution. So if you download the whole Anaconda distribution, you will also get already Orange, which is part of a bigger distribution where you will also find Jupyter Notebook, Spyder, NumPy, and so on. So once you've done that, once you've installed your Orange solution and you want to start this, for example, with the Anaconda Navigator, you can create some small machine learning pipelines, and Orange already has some toy data sets already included. And this is what we are going to do right now. So let's start it Orange within Anaconda. I would highly recommend to install Orange 3 because that is the latest version. Once you started Orange, obviously you can click on tutorials, examples, or you can create a new pipeline. This is what we're going to do now. So on the left hand side you can see different sections. For example, data. Data helps you to load all types of data, if it's CSV data or from a database, or if it's from the top format, a specific Orange format. You can also clean data already. You can select rows. You can do some ranks. You can merge data, and you can transpose data, impute and pre-process and transform data, which is very important if you think about pre-processing and data cleansing. So it supports you in most of these cases, but you can also code in Python within it. So you can also create Python code directly in Orange if there's a need, and you need, for example, to write a specific script which does some jobs. So that is also an additional thing, and by using that it becomes very efficient and extremely powerful, because most of the things you can already do with Orange, but in combination with Python it's extremely powerful because you can do almost anything with that then when it comes to data cleansing and data pre-processing. So what else can you do? You can visualize data, very different plots, scatter plots, distributions. You can create projections, silhouette plots if you think about unsupervised learning. In terms of models, you can store models, save models, load new models, and then you have a whole bunch of different classifiers. For example, a constant, a dummy classifier which predicts the most frequent class, or you have a simple classifier such as the k-nearest neighbor classifier. You can create trees, ensemble classifiers such as random forests, support vector machines, linear regression, logistic regression. A naive Bayes classifier, you can use AdaBoost as another ensemble. You can also train a neural network with different activation functions, different hidden layers and neurons. And if you click into evaluate, you have different test scores: area under the curve, accuracy, performance, F1 score. You can check for different predictions on an input data set. You can look at a confusion matrix. You can create an ROC plot. And unsupervised learning, obviously the standard k-means. You can do a standard k-means algorithm to detect clusters in your data, plus a lot more. So in today's tutorial, we will only cover a very, very small snapshot of what is possible in Orange. So first of all, I want you to click on data and create file. Once you've done that, I want you to also put a data table icon here and combine file with data table. Once you've done that, we still need to define a suitable data set. If you double click on file and you pick from a whole list different data sets, I want you to pick the WDBC data set. That stands for Wisconsin Diagnostic Breast Cancer Data Set. If you do that, you will see a whole number of different features here and also a class label, which is the diagnosis. So obviously what you don't see here is a further description of this data set. If you want to check out a description for this data set, I recommend you to go to the UCI Machine Learning repository. And if you do that, you will find UCI Machine Learning repository, breast cancer Wisconsin. If you do that, you will end up on a website that not only contains the raw data set, but also a further description. On this website, we can see we have 569 instances, we have 32 attributes where only 30 are features, and this data set comes in different flavors with more or less features depending on the individual pre-processing. And clicking on the original CSV file, you can open this and you can see here the raw data. For example, the first patient here, that's the patient identifier, that's the class label, the diagnosis, which is a malignant case, and you can see here all the individual features for that particular patient. So this raw data set, as it comes in a CSV file, was already pre-processed within Orange and put into a new data set called TUP, and that is quite useful because those people who provide this data set define that the individual features are, for example, of numeric, of type numeric, but you can also change this to categorical, and they also said clearly that the diagnosis is our target, so that's our class label that we want to predict. That data set has a couple of characteristics, and one of this is it's a perfect data set in a sense that data cleansing already happened. Though in the real world, you would need to do that, and that is extremely time consuming. Here, other people already did that. So if you look at the individual data set, you will not find any missing data. Missing data has already been removed by either exclusion or imputation. And that's a very, very nice data set. But that also means we will achieve a high performance score for that individual data set, maybe something that you wouldn't get so easily with another data set. So if you do this, the first thing I want you to do to click in data table and to explore a bit the different data and to see that there's a different range and what the features mean and so on. So all that is called data exploration. Data exploration is quite important for you to understand the data before you actually start to predicting something. So you can also visualize, for example, two-dimensional feature space by creating a scatter plot and distributions, and if you open visualization and a scatter plot, It gives you two informative projections by using the feature radius and texture, and just by looking at that you can see maybe there is a potential decision boundary here defined by a hyperplane or by a hyperellipsoid, which already gives you a good prediction by just using these two features. You can also check out individual instances here. Obviously, we also will not be able to find a perfect hyperplane here, for example, with an SVM. So there will still be some mismatch and misclassification which would happen even on a training data set. Data exploration is quite important for you to further understand the underlying characteristic of this data set, and obviously it's quite helpful if you want to further understand the complexity of the underlying structure of that data set and what type of features are especially suitable for this classification task. Because what we are now trying to do, we want to use this data and we want to train a classifier on that. We want to look at a decision tree and different classifiers and to see how they perform on this individual data set. So I would suggest we start with a very simple decision tree. For that, I want you to tidy up the desktop, so remove some of that we don't need any longer, data table, scatter plot, and so on. And you have to click into model and pick as a first start, we want to start with a tree, with a decision tree, combine file with a tree. So what is happening here in the background? We already have a tree now, but you don't see that here. We need to visualize the tree. How do we do this? Visualize, we pick tree viewer, combine tree with tree viewer. And if we double click here, we already see a simple tree based on this data set. So that simple tree was derived from this data set, and we can see all the data was used, though there is not a split into training and test set yet, but we are still at the start of our tutorial. So you can see that the feature worst radius contains a lot of information and helps us to split the data into different branches. And if we use further features, we can already arrive quite a good prediction. For example, by following this tree here, 98.5% of the cases would be benign. So from 333 instances, 328 are already benign. And the opposite case would be true for the malignant cases if we just use these two features. We can also further look down into a more developed tree with 4 levels or with 5 levels, and to further break down that structure. And the deeper we go, the more developed our decision tree would be. But obviously this might not be the best decision tree if we were to test this on unseen instances. So that is a first idea how we create a classifier. Especially the decision tree is quite useful because it gives us in one picture, in one decision tree, a very useful model which has a huge advantage, and that comes with interpretation. You will find many classifiers which might perform way better than a simple decision tree, but the importance here is can we actually understand this model when we talk with clinicians. So if we have a trained artificial neural network, it might be hard to communicate the trained model to a clinician, but obviously that here would be a huge advantage when we talk with a clinician or with a patient about the individual decision making. So what we want to do now, I want you to tidy up again your desktop, and I want you to put in a test score. So we take the icon test score, we combine file with test score, and now we want to pick a number of classifiers. It's always a good choice to start, for example, with the k-nearest neighbor classifier. Why is that? Because it's a very simple classifier, and at least our more sophisticated classifiers should be better than the KNN, otherwise there is something fundamentally maybe wrong. So what you saw here very shortly was a calculation, and if you click on test score, you can see that the k-nearest neighbor classifier has an area under the curve of 0.965, which is extremely high. Even so, that's a very, very simple classifier. And we used as a hyperparameter here 5 neighbors and just Euclidean distance. Why is it so high? Because the data set is such a good data set and so clean. If you look at the confusion matrix, you can also create a confusion matrix. Should be somewhere here. Yes, it is. If you combine test score with confusion matrix, and if you double click on the confusion matrix, you can see that the true positives, the true negatives, the false positives, and the false positives. So that is quite useful because the confusion matrix tells you immediately in one table how well your classifier performs. Obviously, if you were to change the hyperparameters, let's say you change it to 7, this immediately affects your confusion matrix as well as your test score. If you look into individual predictions, if you pick the icon predictions, and if you look in some of the predictions, you can see how well your individual prediction works for an individual instance. For example, here we have a malignant diagnosis and our k-nearest neighbor predicts also malignant, and so on. But sometimes we have, if you scroll down further here, you will find some misclassification that is also happening. If you want to look at the ROC curve, you can also do this quite simply by combining test score to ROC analysis, and immediately you get an ROC plot. So that's very convenient. And if you were to code all of that in Python directly, it would take you a long time. And this year, we just created this as a first proof of concept in a couple of minutes. If you want to look for another classifier, if for example a support vector machine, or you want an ensemble such as the random forest classifier, or let's say you also want a naive Bayes classifier, if you do that, immediately you train these classifiers here, and once you've done that, you can also compare them to each other, the individual performance, and you can also look at the confusion matrix for each individual classifier. So looking at that, you can see that the support vector machine is obviously much better as the k-nearest neighbor, but this could just be a lucky pick because maybe the hyperparameters were just quite well picked for the support vector machine. It could also happen that we have maybe a different kernel, and then suddenly our score would drop or go down. So because this is all untuned, so what we don't have here is hyperparameter tuning, but you can do this to some extent manually by changing the individual hyperparameters of each classifier. For example, for the random forest classifier, the number of trees generated and all of that. So it's also quite useful if you want to have a neural network. Let me tidy up that a bit here. Let's pick a neural network, and the neural network you can also further configure. You can see training takes a bit longer for the neural network, and it's not necessarily better than the k-nearest neighbor. Well, in this case it is quite good because we didn't do any hyperparameter tuning here. So here we have, for example, 100 neurons in one hidden layer. If you want to change that, maybe 10 neurons on 20 on the second hidden layer, you can change the activation function, and if you do that, it should automatically rerun the training, and we get another neural network with another score, which is much better now, but the confusion matrix also is not too bad. So that is just a very, very small snapshot and introduction into Orange. You can do much, much more. You can, for example, also do unsupervised learning. here and create different clusters. And what is always useful, as I already said, if you're really stuck and something is not provided by Orange, you can also create a Python script, and your data flows into the Python script, and you can do all kind of operations here. You can code directly in Python here and run this code, but you can also use input variables and output variables if you have a individual case-specific data pre-processing that needs to happen, or a specific classifier you want to implement. For the evaluation, you obviously here we use cross-validation, but you can also change this to a different type of cross-validation, or a fixed test set, fixed training set, leave one out method, or random sampling. That's all possible. And if you want to further configure, if you want to further adapt your individual pipeline, as I already said, the Python script here is extremely useful, and automatically you can further refine your machine learning pipeline. That's all for now. I hope you enjoyed that session. Please try to mimic what I did here and create a very small pipeline. Why is that useful? Because for the assignment, I want you to create a pipeline, and you should pick 2 algorithms of your choice, maybe the k-nearest neighbor classifier or the neural network classifier, and create a pipeline, create a screenshot of what you did, save it as an Orange file, and describe it in accordance with the requirements which are provided on the e-learning platform. That's all for now. Thank you very much for listening.